Hello everyone, welcome back to this video series on clinical SAS SDTM programming. As part of this video series, we are taking a look at the SDTM programming general concepts which are reused across different SDTM domains. So in this video, we will see about the lesson which is related to creation of a supplementary domain. So let's jump into the background. So SDTM standard has standard domains, which is standard datasets. Each standard domain is based on a class. It is findings, events, or interventions. So there are special purpose domains as well, but we'll restrict the discussion to any of the three findings, events, or intervention domain classes for this video. So each class has a set of variables that are allowed to be used in an SDTM dataset that is based on that class. So other variables which are not part of the standard set of variables for that class cannot be used in the dataset. As part of the clinical trial needs, there can be data points that are needed for the study, but there is no standard variable to map the information to. The variables that are used to store the information that cannot be mapped to standard variables are called non-standard variables. SDTM allows to store the information from these non-standard variables into a dataset called supplementary dataset for that domain. And each value in these non-standard variables is linked to the record in parent domain by an identifier variable like sequence, group ID, or ref ID, or SPID, etc. The information in these non-standard variables are presented as rows in the supplementary data. One row for each non-missing result of each non-standard variable. So the structure for the supplementary dataset is one record per identifier variable, identifier value, and QNAM per subject. So what are we going to learn in this lesson? In this lesson, we will see how to create a supplementary dataset for a parent domain using conditional output statements. Let us jump to the input data that we are going to use for this lesson. So we have a dataset called EC, which has some standard variables like subject ID, EC seek, treatment, dose, start date, and end date. Along with these standard variables, we have three non-standard variables, which is collecting information related to dose interruption. So there is this first variable, which is called EC dose int, which is used to store the information on whether a dose was interrupted. And there is a second variable which is called ECINTRS. There is a second variable called ECINTRS which is used to store the reason for dose interruption if it is interrupted. And there is this third variable which is used to capture the information whether the dose is resumed if it was interrupted. So this information EC dose int, EC int rs, and EC dose res are all related to a particular record. So in this case, so we can link these three pieces of information to the variable value in EC seek. So the identifier variable is EC seek and the identifier variable value is 1 here for subject 1001. And as seen in the background, so we create a row for each non-missing non-standard variable per subject. So here in this case there are three variables which are populated. All three non-standard variables are populated, which means these three will become three rows in the supplementary data set. And in the second case, the information for second and third variable are missing, so we do not create an additional a row for these variables or QNAMs. So let us now go to the form output and then try to manually identify or create the structure. So as discussed in the lesson description, we have seen that we will create a record for each non-missing non-standard variable per identifier variable. So here EC seek 1 of subject 1001 has three pieces of non-standard information for EC DOS INT, EC INTRS, and EC DOS RES. So three records will be created, and each of this information, the name of the variable is becoming the QNAM. So EC DOS INT, EC INTRS, and EC DOS RES. And the value in this variable will be stored in the variable called qval in the supplementary dataset. So ECINTRS has a value of local irritation. So we'll have to populate qval for that qnam, which is the non-standard variable, as local irritation. And then ECDOSRES for q idvar of ECSeek and idvar val of 1 for subject 100 is y. So we'll have to populate it with y. So and for subject 1001 and with ECSeek of 2, only one variable has non-missing value. So we'll only have a row for that variable only. So ECDOS INT has a value of n. So we'll have to carry forward that value n to this qval variable. Similarly, based on the specifications requirements, we can populate the q label. So if the information is being carried or collected in the CRF, we would populate the origin as CRF. Otherwise, if it is assigned or derived, we would populate the q origin with the relevant value. And there can be some cases wherein the response or the non-standard information is the opinion of an investigator or a radiologist or the subject itself. So in that case, we would assign the relevant value in the QEval variable with the values like investigator, study subject, or radiologist or adjudicator, etc. in the QEval variable. So basically it is trying to capture the person who has provided the response, which is displayed in the QEval variable on a particular row. So this is how we can manually try to identify or create the supplementary dataset. Now let us jump into the programming aspect and see how this can be created. So here if we see, so this structure, the code structure is very much similar to the case where we have derived test CDs based on the information present in variable, that was wide to long transformation. So the structure is similar here. So we are using conditional outputs and creating one row per each variable for each non-missing value in that variable. So here, so we had three variables, ECDOSINT, ECINTRS, and ECDOSRES. So we have three sections of code with an output statement for each of that. So to create a separate record. So when we are trying to use the value from ECDOSINT, we are assigning the QNAM of ECDOSINT, and then we are giving a label of dose interrupted for that QNAM. At the same time, we are saying that the identifier variable is ECSeek, and we are using the value from ECSeek variable and assigning it to the idvar variable. And similarly for qval, we are using the variables ECDOSINT's value, and then as this information is collected in the CRF, we are assigning a value of CRF to the origin. And then as information related to evaluator is not present, so we are leaving it blank and then outputting a record. So similarly, we are doing it for ECINTRS and ECDOSRES. So for each non-missing value in the non-standard variable per subject and identifier, we will get a row. So let us take a look at the intermediate datasets that are getting created out of this code. So we have our sub EC01. If we see, so in total in the EC dataset, we had four non-missing values. So we are getting four records out of that entire data set. So the first record has three non-missing variable values. So the first record is getting triplicated, once for ECDOSINT and once for ENTIRS and once for ECDOSRES. And the second record with a ECSeek of 2 for subject 1001 only had one component of those three non-standard variables present. So we are only having a record for that QNAM. So if we keep only the required variables, the sub-PC dataset would look like this. One record per subject, per ID var val, and QNAM. So this is how we can programmatically create supplementary dataset from a parent dataset. So originally these input variables which become QNAMs have to be created in the same way like how we create other SDTM variables. Once we have all those variables created, we can make use of conditional output statements and then create this sub-PC structure. Thank you for watching. Keep learning.